Hello, I am Rohan Sarkar from the Robot Vision Lab. Today I would be presenting a video analytics software architecture named CheckSoft that is designed to observe humans interacting with objects using computer vision. The video analytics market is growing at a rapid rate of 22%, and because of the increasing demand, the number of video cameras used is increasing by 12% per year. However, current solutions can't process huge amounts of data that is being captured and stored every day, and hence vital information that could be derived from such data is being missed because it is simply never viewed. This fuels the need to develop scalable software systems that can automatically process video streams for a variety of applications in order to automate certain daily operations as shown in the pictures on the right side. Such software systems can be used to automate an airport checkpoint security, where people divest their belongings into bins and collect them after the screening. In such a case, the software system would monitor if the passengers have collected all of their own belongings or left something behind, or if the items are being misplaced or stolen. Similarly, such systems could automate retail operations in which a person can just enter a store, pick up some items, and leave the store, and the software would automatically bill the customer once a leave. And similarly, it could be extended to smart libraries, smart museums as well. Such systems can also be used to analyze and understand customer interests, which could be used for improving business operations and inventory management. Based on some initial customer interviews, we believe that the market size is very large and the software we have developed can be applied to automate nearly any people-centric process that needs to be automated. Apart from the airport checkpoint security application and retail automation, our software could also be used for monitoring person-object interactions where people might be interacting with certain exhibits or books in a library, as well as surveillance in museums where people are not supposed to touch expensive exhibits. Additionally, it could be used for surveillance to ensure safety of children playing in school areas and factory workers working in precarious situations. From the rough estimates of the market reports published in 2017, the total available market, which comprises of video analytics solutions at a global level, is around $1.3 billion. And the serviceable market, which includes only software solutions, at a global level is $406 million and $70 million only in the US. The software architecture that we have developed is highly scalable and can process video data to track person-object interactions occurring simultaneously in busy environments. The pictures shown on the right side are some results of a simulated retail store in our lab. In the picture on the top, one can see that we are tracking people and assigning them unique IDs as shown in the green boxes. We are also tracking their interactions with the items in the shelves that are shown using red boxes. In the picture towards the bottom, we can see that using computer vision and deep learning, we can track interactions with the different objects present in each of the shelves. Some key features of our system is that it is designed to operate with any number of cameras and is scalable with respect to any arbitrary number of people and objects in the environment. Additionally, the software is substantially domain agnostic in the sense that using a few minor changes, it can easily be customized for many different applications. The key utilities of the software is automating people-centric applications to reduce operational costs and enable faster checkout. The system could also be used to gain valuable insight from interactions. For example, in the retail stores, we can understand customer preferences such as what other products did customers review before purchasing something, and in museums or museum or art galleries, which exhibits are the most attractive to visitors. In this comparison, we briefly compare Checksoft with other video analytic companies and products. As can be seen in the first column that only Amazon Go and Purdue Checksoft is designed to track person-object interactions. However, the Amazon Go system is only designed for retail automation, whereas our system can automate many different applications as shown in the second column. Our system can be used for anomaly detection and surveillance since it is additionally equipped to track associative relationships between people and objects. Checksoft can be used in complicated applications such as airport checkpoint security, which other systems are not designed for. Although our architecture is based on computer vision, it can be used with other sensors as well, such as weight sensors or RFID sensors, depending on the application. Checksoft can also be used to collect interaction information, which can be used by businesses to better serve customers. We invite interested parties to contact us regarding industry partnerships and research collaborations. Thank you.
Hi everyone and welcome to our OTC showcase presentation. Our presentation today is on a machine learning architecture for network attack detection, and that architecture basically exploits or capitalizes on state-of-the-art technology in lifelong learning and in deep neural networks to enable an agile and robust and intelligent and diverse, and I'll explain what we mean by each architecture for network attack detection. And many modules in that architecture was actually invented here at Purdue by our team. And my name is Ali Gamal. I'm an assistant professor in Purdue ECE, and this is joint work with my colleague Ali Garyani, who's a Purdue alum, and Professor Arif Gafoor of Purdue ECE. Now, the need or the market need for our solution stems from the lack of any solution in the market that has this lifelong learning property where the solution itself has a mechanism of updating itself. And when you do that, then you basically have a performance guarantee against intelligent or adaptive attackers that change their strategies. So another way to phrase it is basically there is no autonomous way of integrating between attack detection and discovery. Current solutions rely on detecting attacks on a one-by-one basis in a hard-coded way. So you find out a new attack, and then you hard-code a way to handle this new attack. So you need these frequent updates, which can be very cumbersome and costly, and at the same time you don't have a guarantee against intelligent attackers, and specifically against what's known as a zero-day attack, which is basically the name comes from the fact that the attack happens at the 0 day of shipping the project. So in particular, there is no API first, and then API is a software suite. There is no API first architecture that basically facilitates the integration of state-of-the-art machine learning with current network security solutions. And also the current solutions do not adjust well with the environment that they operate in a sense that they are not learning how to adjust the system parameters, and they are not learning to incorporate feedback from possible human operators. So basically what we introduce is a software suite or an API package that provides flexibility with integration. And we capitalize in terms of timing on a very hot market, which is the cybersecurity market, that's growing at a very large rate and expected to reach 259 billion by 2025. And we are also capitalizing in two very important emerging markets that are important for our nation. And basically, one is the market of zero trust security solutions, which are basically security solutions. Zero trust comes from not even trusting the legitimate users. So these are security solutions that try to build profile for the legitimate users of the solutions. And the other emerging market is the private 5G or wireless autonomous networks. And in our solution, there are many custom tailored parts just for the case of deployment to wireless networks. Our go-to-market strategy that we envision is a business-to-business strategy, where the first step would be licensing to a major provider of network security solutions like Cisco, Norton, or Akamai. The potential end users are also very large players in the market like AWS, Microsoft Azure, and Google Cloud. Already we received significant interest from the Army Research Lab, ORNL, and Interdigital. Now, the architecture that we present has five distinctive features. One is lifelong learning. It can update itself to have a long lifetime by updating the machine learning components themselves. It relies on both supervised and unsupervised machine learning modules to detect both attacks for which we know the signature as well as anomalies. It relies on diverse feature extraction, which adds robustness, and it's agile in dynamic environments, which is a very important feature, and robust against smart attackers. Two distinctive features that I want to highlight here is having what we call a rule-based brain, which is basically a component that takes recommendations from the machine learning components and then decides on the final decision. So the machine learning, so that adds guarantee against any glitches that can happen to the machine learning black boxes. And at the same time, it provides the lifelong learning updates to these components. The other distinctive feature is what we call the curiosity-driven honeypot, which is basically relying on a new mechanism in machine learning called curiosity-driven reinforcement learning. And the goal here is same as curiosity in humans, to maximize the information gained from expected responses. So we lure the attacker into a honeypot. So we have this stealth constraint that any traffic we issue in the honeypot looks normal to the attacker, and at the same time we are collecting information about the attacker. That helps us handle these intelligent attackers as well as zero-day attacks that we have not seen before at the time of training the machine learning models. Now, to summarize the comparison with existing solutions, we chose to have two categories of solutions: the traditional solutions and the more recent ones that have machine learning, and then our Purdue LiDAR invention. Now, we want to highlight three features for which distinctive features about our invention for which we have an edge over existing solutions. One is detecting zero-day attacks that we haven't seen before. Even though machine learning, like solutions that rely on machine learning, have this feature, but in our case it will be stronger because we can update the machine learning modules automatically. So we have a way to keep detecting zero-day attacks for a long lifetime. And one of the very important features that reflect directly to cost is that there would be the need for frequent updates would be alleviated significantly. And the last is the suitability for zero trust security, because here we can afford zero trust, which means that you don't have trust even for the legitimate users, because we can build trust through predictability. So we can build profiles for users through the lifelong learning based machine learning models. They can learn to build profiles for users. So it fits perfectly in the emerging market of zero trust security solutions. The ask is seed funding to start building a prototype. We have already started, but seed funding would help tremendously. And we are also open to collaborations to speed up that implementation. And we believe that a business-to-business go-to-market approach would be best, and hence we are looking for licensing opportunities with major providers. Thank you.
Hello, thank you for participating in the Purdue Technology Showcase, and thank you for listening to my presentation. My presentation is titled Low Power Logic Family with Current Controlled CMOS. There are a growing number of devices part of the IoT, and the large market for these IoT devices represent an opportunity to participate in that growth. To achieve a significant market share in the global Internet of Things with electronic components, it's necessary to offer major performance differentiation compared to your competitor. In our case, compared to standard CMOS 8s. So again, we're after that elusive competitive edge. the market size, the forecast for spending in the IoT solutions are virtually limitless. For example, in the year 2025, the revenue is expected to be over 1 trillion. That's trillion with a T. So as a way to gain our competitive edge that we seek, we can do that by using 3C logic from Purdue, the technology from Purdue. It's important in general to optimize the energy usage, and necessary to do this, it will be necessary to operate in a game called sub-threshold mode. And up until now, the performance variations in the sub-threshold mode has been a major challenge. Well, the 3C logic technology offers a way to solve this problem, and that 3C logic is 10 times improved in variant over process compared to standard CMOS. The simulation waveforms on the slide demonstrate this. The input is at the top, the 3C logic inverters are in the middle, and then the standard is at the standard CMOS is at the bottom. And these waveforms illustrate clearly that the 3C logic is significantly improved variation over the process. Another advantage that goes along with the reduction in variation is an area improvement. Pretty much from needing, to use smaller PMOS transistors. So this slide is a way to capture briefly the performance differentiation that's been achieved, and which will allow one to compete in the IoT markets. The variation in the delay is greater than 10x improvement, and the reduction in area of up to factor 3. I would be interested in collaborating between myself, Purdue, and an industry partner, pursuing a development license for this 3C logic technology. The patent that Purdue received was granted as shown here. And also, there is a journal paper that's been submitted. I'd be happy to send that along if there's interest in reviewing that. So again, thank you for your time.
Hello, welcome to the 2021 Purdue Technology Showcase. My name is Yongxiang Lu. In this presentation, I will introduce the technology, real-time video analytics for validating information. The technology can provide real-time video data in many parts of the world so that people can validate information about these events while they are happening at these locations. As you can see in this slide, the first two photographs were taken on the last day of 2020 at New York Times Square, and there were few people. The third photograph was taken in 2019, and the place was packed by people, celebrating the arrival of 2020. This is another example. On January 6, Washington, D.C. had many protesters. 2 days later, there was no protester. The data is provided by the traffic camera deployed by the city government. Anyone on the internet can see the data in real time. Now, let's imagine someone posts on social media claiming that there are many protesters in Washington, D.C. on January 8. Users of our technology can check the public data and know that this claim is not true. Misinformation has caused an estimated $78 billion loss each year. Video data can be good tools to help news agencies validate information. Many millions of cameras have already been deployed worldwide and provide real-time information to the general public. The data may be watching highways, downtowns, parking lots, shopping malls, national parks, and many other places. Even though the data is already available to everyone, there is no technology that can access and manage the data at the global scale. The estimated global market for information validation is about $200 million per year. The market in the US is about $100 million per year. This technology focuses on real-time validation, and the market is estimated at $40 million per year. This research team has validated the market through interviews with news editors, reporters, executives of news agencies. This slide shows another example of the contrast of doubling in 2015 and 2020. As you can see, there were few people in 2020. This is how the technology works. We crawl the web to find camera data streams. Then we verify the data changes over time. The data is classified into indoor or outdoor, city or rural, highway or downtown, and so on. Then we create a user interface so that the data can be searched. We record snapshots to establish the known of the scenes. Based on the knowns, we can detect anomaly. For example, a street is usually filled with cars. If there is no car and instead there are many people, this may be a protest. This slide shows the locations and the number of cameras already discovered by the technology. This table compares different solutions. The most common solution is sending a reporter to the scene. However, this can take time and can be dangerous. Another method relies on eyewitness or citizen reporters. This can also be dangerous. We already know that social media is not a reliable source of information. In contrast, this technology can be fast, safe, inexpensive, visual, and reliable. A company has already been created to commercialize this technology. An SBIR proposal was submitted. This technology uses only publicly available data. Anyone connected to the internet can obtain the data. This technology does not identify any individual, and thus there is no privacy issue. For the next step, we are looking for partners to demonstrate this technology at a large scale. We also want to invite users to help us make the technology better. Thank you.
Hello and welcome to the Career and Aptitude Assessment for Cybersecurity presentation. My name is Flavio Lobo. I'm a PhD student in the Technology Leadership and Innovation Department at Purdue University. Dr. Masoud Akhtir is our principal investigator, also from Purdue University, and we're working with Dr. Toby Egan from the University of Maryland on this project. The market need behind this technology is this growing gap that currently exists in the cybersecurity workforce. It is a segment that's been thriving faster and growing faster than any other professional sector. And it currently, there is a projection of approximately 3.5 million unfilled cybersecurity jobs around the world by the end of 2021. The impact is quite significant when we consider the role of information technology in everyone's lives, as well as in the public infrastructure, as well as the private infrastructure. So this workforce shortage has damaging ramifications to people and organizations in public and private sectors. The problem statement that we're working with is this requirement for rapid skilling of professionals to build a cybersecurity workforce. And it is a multi-pronged effort. A key part of this effort is identifying the knowledge, skills, and abilities that are critical for jobs in cybersecurity. And also, as important as the KSAs is the fact that there currently isn't a digital platform to help individuals explore their career options and better understand their aptitude, especially for cyber related fields. Our technology then is the Career and Aptitude Assessment for Cybersecurity. It aims to provide individuals who have interest in cyber-related fields with a tool for self-assessment about their personality traits, career interests, and perceptions, as well as an opportunity for them to validate their knowledge, skills, and abilities as they relate to cybersecurity. The inventory is made up of 4 different sections. In each one of these sections, we use scales that have been previously validated, so they are well used and well tested. The first section is based on 2 scales, and we aim to assess and provide feedback on personality traits. The first scale that we use is the Big 5 factor structure, which is an inventory that measures an individual on these big 5 dimensions of personality. So we're going to be looking at things such as openness versus closeness to experience, conscientiousness versus lack of direction, extroversion versus introversion, agreeableness versus antagonism, neuroticism versus emotional stability. And we also use one scale to help assess the proactive personality of a given individual, which basically gives them feedback on their disposition towards proactive behavior. The next section looks at interests in general. For that, we use the ONAT Interest Profiler, which is a set of tools. Of that set of tools, we use one specific scale that looks at a 60-item instrument, and the results of that instrument is compatible with the RIASEC interest structure developed by Holland. RIASEC stands for Realistic, Investigative, Artistic, Social, Enterprising, and Conventional, as types of interests that an individual may have. From that point, we then move into the career section of the inventory, and we use 2 scales to look at the subjective career success inventory, or perceptions on career progress and status that an individual may have, as well as their career satisfaction perceptions, which is measured on a different scale. The last section of the inventory is a cybersecurity specific set of components, all derived from the NICE framework. And we have a section that looks specifically at cybersecurity knowledge, a section that looks at skills, and for abilities, we actually use a different instrument, and we look at 3 specific types of abilities: arithmetic, reasoning, verbal abilities, as well as computation. We have not field tested the inventory yet, so we're looking for collaboration opportunities in industry and academia to operationalize and test the aptitude assessment. Thank you very much for your time, and we look forward to engaging with you in any questions you may have. Thank you.